Welcome to the Data Lifecycle journey, where we explore how raw, unorganized data evolves into powerful insights that drive decisions and innovation. Whether you are a data engineer, analyst, or just curious about how organizations handle data, understanding this lifecycle is essential. Think of the data lifecycle as a recipe for cooking a meal. You start with raw ingredients. That's your data generation. You collect and store them, prepare and cook them. That's ingestion, storage, and processing. Then you plate, serve, and enjoy the meal. That's consumption, visualization, and finally cleaning up or archiving. In this video, we will walk through 7 key stages of the data lifecycle, which is data generation, data ingestion, storage, processing and transformation, consumption, visualization, and archival. Each stage has its own purpose, tools, and best practices, and together they form the foundation of every data driven organization. Coming to the stage 1, the data generation, where it all begins. Every data story starts with generation, the birth of data. This is where information first comes into existence through applications, devices, or people interacting with systems. Imagine you are running an e-commerce website. Every time a customer adds a product to their cart, clicks on a recommendation, or checks out, that action generates data. You capture details like user ID, product ID, the timestamp, device type, and even the location. In real world, data can be generated in many ways. Internet of things, sensors, recording temperature or humidity every second, mobile apps, logging user interactions, website for tracking clicks and conversions, or business systems storing transactions, payments, and messages. If we compare with real life, it's like a security camera constantly recording what's happening. Every frame is new data. At this stage, the focus is on capturing everything accurately because every insight later depends on what you record now. Coming to the stage 2, which is data ingestion, collecting and bringing it together. Once data is created, we need to bring it home. That's what data ingestion is all about, collecting information from multiple sources and moving it into a centralized location for further use. There are two main approaches. One is batch ingestion, second is streaming ingestion. Coming to the batch ingestion, where data is collected periodically, for example, every hour or a day, and streaming ingestion, where data flow continuously in real time. Let's revisit our e-commerce example. Every night at midnight, an automated pipeline could pull order data from MySQL database, extract clickstream logs from web servers, collect payment details from an external API, and store everything into an Amazon S3 bucket as JSON or CSV file. It's like collecting mail from multiple mailboxes and bringing it into a central sorting facility. You might not open it yet, but now it's all in one place. Typical tools used at this stage are Apache Kafka for real-time streams, Airflow for orchestrating batch jobs, and services like Fivetran or Informatica for automated ETL. This stage ensures Data is gathered, organized, and ready for the next step, storage. Coming to the stage 3, data storage, giving data a safe home. Now that's our data has arrived, it needs a home. That's data storage. Storage systems are designed to keep data safe, durable, and easy to retrieve. In modern architecture, we often see a layered storage approach. The raw layer, often in a data lake like AWS S3 or Azure Data Lake, holds all ingested file as is. The processed layer, stored in warehouses like Snowflake or BigQuery, contains clean and structured data. The archive layer, using services like AWS Glacier, stores very old data at lower cost. Think of it like a library system. Recent books are displayed upfront for quick access, which is hot data. Some are in the back room, which is warm data. And older books are stored in deep storage, which is cold data. The goal here is to balance cost, performance, and accessibility. Good storage planning ensures you can retrieve any dataset no matter how old when you need it. Coming to the stage 4, which is data processing and transformation, turning raw into refined. Once the data is stored, it's time to make it useful. Raw data is messy, it contains duplicates, missing values, or inconsistent formats. That's where data processing and transformation comes in. At this stage, engineers clean, validate, and enrich the data. They remove errors, standardize fields, and join datasets together to create meaningful tables. For example, remove duplicate orders or incorrect timestamps, fix missing customer names, join customer order and payment data, calculate total revenue or conversion rates, and format currencies consistently across regions. This process can involve ETL, which is extract, transform, load, or ELT pipelines, which is extract, load, and transform. Common tools includes Apache Spark, DBT, Pandas, and Databricks will be used for this process. If you think of raw data as crude oil, processing refines it into a usable fuel, which is like clean, standardized, and ready for analytics. This stage is often the most technically challenging but also the most rewarding because this is where data starts gaining real value. Coming to the stage 5, data consumption, serving it in the end users. After data is refined, it's ready to be consumed. Data consumption means making curated data available to business users, analysts, and data scientists. For our e-commerce company, we might create tables like daily sales summary, which is total sales, orders, and customers per day, top products, which is best selling items, then customer lifetime value, helping marketers target loyal customers. Analysts can query these tables using SQL. Data scientists might feed them into a machine learning models, and product teams might access them through APIs or data marts. This stage is all about accessibility and usability, making sure data is not only clean but also easy to find and understand. It's like preparing a restaurant menu. You have cooked all the dishes, and now customers can simply order what they want. Coming to the stage 6, which is data visualization and analytics. Insights come alive. This is the stage where data truly comes to life, which is visualization and analytics. Numbers turns into visuals and visuals turns into insights. Dashboards and reports help decision makers spot trends, compare performance, and respond quickly to the changes. For example, revenue trends shows as a line charts, sales distribution displayed as a heat maps, conversion funnel analyzed through Sankey diagrams, and real-time inventory alerts triggered by low stock levels. Visualizations tools like Tableau, Power BI, Looker, or Metabase makes this possible. They bridge the gap between technical data and business understanding. Think of it a car dashboard. You don't see every mechanical details of the engine, but you get clear indicators of what matters most: speed, fuel, and performance. That's exactly what dashboards do for your business data. Coming to the stage 7, which is data archival and deletion, the final destination. The final stage is archival and deletion. Now, all data needs to be live forever. Storing everything indefinitely is expensive and often against compliance rules. At this stage, data is either archived for long term retention or deleted permanently. For instance, orders older than 7 years may move to AWS Glacier. Clickstream logs may be deleted after 2 years under GDPR. Personally identifiable data may be erased upon user request. Archiving helps reduce costs and keep your system clean, while deletion ensures privacy and compliance. It's like cleaning out your garbage, keeping what essential, donating what's useful, and throwing away what's no longer needed. So we are using NYC taxi data pipeline, which is end-to-end architecture in this data engineering project. So let's look at the big picture. So we have our data source, which is NYC taxi, and we have ingestion through Python plus Airflow. Then we are converting the on-prem data into raw data lake in AWS S3, and we are processing using PySpark for cleaning purpose, and the cleaned data is moving into Silver's layer, which is Databricks S3, and which is going into a data transformation for through DBT, and the final data will be moved to a gold layer, which is Databricks, which is data warehouse analytical storage. Then we are moving into the visualization, the front end business dashboards or reports through Power BI. This will be accessible to the all the stakeholders. To wrap up, every data driven systems follow this life cycle no matter the scale. Different stages requires different tools. Choose the right one for the job. Data quality improves as you move through the pipeline from raw to refined. Not all the data needs to reach every stage. Some can be archived yearly. And most importantly, the data lifecycle is iterative. Insights from one cycle often inspire new data collection and innovation. To conclude, understanding the data lifecycle helps you design better systems, manage data responsibly, and extract the full value of information. So, next time you work on a data project, map out which stage each component belongs to. You will see your architecture come together like never before. Thanks for watching Data Lifecycle Journey. And remember, great insights starts with great data. Thank you.